You can see my screen, and I want to welcome you all to our first, really, uh, discussion conference series, however we'd like to think of it, of AI and biocuration. We're lucky enough to have corralled an excellent group to take us through a number of aspects of this today. And I'm going to be short. I'm Marc Gillespie. I am lucky enough to have worked with a bunch of folks who helped organize this session and move it through. Before I jump into the absolute for today, I'm just going to give you a peek at upcoming events as well that will be running sort of this spring and will sort of be carrying through our time here. The virtual conference is what we're doing today. We plan on another session on March 9th. Please note that our conference, the ISB conference, is happening this April. We have a virtual conference series that goes with that, and we'll have virtual posters. And then we have Charlie Hoyt's entry into Curate This, a sort of live examples of biocurators in their own environment, curating in the wild in a discussion context. So we'll send you the link. Sue Bello, our fearless leader for ISB, is featured in our first session. And let's talk about today. So today, I'm lucky enough to welcome you. We'll have Chris Mungall lead off. Pengyuan Li will take it from there, and then we'll have Aleix Puig-Barbe, who will take us through, and Christopher Tabone will close the tale on scalable literature curation. And then we're going to have time for discussion at the end, so you can take us through any sorts of questions, and we'll be able to talk through them and see. It's a discussion, and this is always going to be a discussion for all of us. So I think we're lucky to have this time to talk about it. I'm going to hand things over to Lenore, who's going to be emceeing us through. And I want to welcome you all and thank you for being here.
Great, thanks a lot. Chris, while you're getting your slides up, so I'm just going to introduce, as you know, Chris Mungall, who's going to give us a talk about staying in the loop, a biocurator's guide to agentic AI developments. And just as a reminder, feel free to, like, as you think about things, put questions into the chat. I guess you could try to upvote questions there if you want. We'll get to them in the end, but we'll also have time for people to raise their hands and continue on. So without any more delay, here's Chris.
All right. Thank you, Lenore and Mark. Yeah, and thanks everyone for allowing me to come in maybe a little bit at the last moment to air some of my views on some of the latest developments in agentic AI. And so for those of you who don't know me, I'm based at Lawrence Berkeley National Laboratory. I'm the PI on a number of different projects. Some of them are knowledge-based or data resource oriented, both in the NIH and Department of Energy realm. But what I'm going to talk about today, this is mostly my own views and don't represent the views of my employers. I may kind of like go into, we may get into some kind of like discussions of some aspects of AI, and this is very much as Lenore says, a kind of like a kind of conversation where we can all kind of like share some of our opinions and views. But just to really just dive in and get started, most of you are probably, I assume everyone on this call is now very familiar with using kind of like chat-based AI interfaces like ChatGPT. These are fantastic for some kinds of operations, if you use them skillfully, you still got to watch out for hallucinations and so on. But they're particularly good for certain kinds of tasks that involve things like uploading a document and trying to summarize the information in that document, extract tables and so on. They're also pretty good for kind of like high level broad knowledge and so on, but they are still fairly limited, although it has to be said, less so than before. They tend to be prone to hallucination, especially if you prod them and push them in a certain kind of direction. Because they are running on the web and not running locally on your machine, they maybe have limited ability to kind of explore your data sets, your knowledge base, to update the data tables that you care about. They're not really able to incorporate the latest knowledge from the literature, although this is changing. You'll see now, if you use ChatGPT more and more, it may invoke some kind of like a search where it goes off and searches the web, or maybe even PubMed to kind of like back up some of its answers. And I think it's very worthwhile kind of being aware and having a kind of good mental model of when that is happening and when that doesn't happen. But nevertheless, even though we're starting to see these more agentic capabilities in chat interfaces, typically they lack the context about you personally, and your motivations and your own use cases to really kind of give you the answers that you need in many cases. And finally, while they can be good for kind of quick question and answer type tasks and look up and search and so on, they won't be able to carry out complex end-to-end tasks that involve like multiple steps and so on. So by all means, keep using ChatGPT or your favorite AI web client, but do not use it to the exclusion of all other tools. And in particular, we're starting to see a slew of tools that make use of a paradigm called Agentic AI. So the basic idea with Agentic AI is fundamentally quite simple, but it's actually kind of quite hard to reason about how impactful this is and the kind of applications of it and so on. But the basic idea is that an agent is a program that you will give it a task, and this could be quite a large open-ended task, and that agent will run in a loop. And in that loop, it will essentially make calls to tools. And here, tools it can really be anything. Tools could be things like searching databases. It could be searching external databases on the web. If you give it access, it could even be searching your own knowledge base or data resource. It could even be tools for kind of like updating files, like maybe local files on your system, or even tables within your database, if that is allowed. And it will essentially run through calling these tools, but it will make use of an LLM to decide which tools it should use next, and it will make use of an LLM to interpret the results of those tools. So it essentially manages the LLM prompts for you. You prompt the thing at the very beginning, but most of the time it's actually generating the prompts and making use of those. And crucially, it also manages kind of state as a kind of like internal memory as it goes along. So it maybe keeps track of its tasks, and increasingly we're seeing that these agentic AI tools can start to make kind of complex plans with and outline all of the different tasks and subtasks and keep track of which ones are done, and maybe even run things in parallel and so on. So here's a kind of like example on the bottom for a kind of like an ontology-oriented task, and I will maybe tend a little bit towards ontology-oriented examples, although this really applies to kind of like all curation. And I think we're going to hear from Alex kind of examples of this kind of workflow here. Another thing that is a really kind of crucial conceptual shift here that is hard to kind of like really grasp until you start using these is that I like to think of this as a kind of like autonomy dial that agents can give you. And people develop different workflows for using agents in different kinds of situations. And there's different kind of flavors of workflows. One of these, could be characterized as a kind of like YOLO, you only live once workflow, where you basically get it to perform a complex end-to-end task, and you give it virtually no supervision during this task, and maybe only check the results at the end. Then there's things like a kind of like a planning mode type workflow, where you do heavy iteration with the agent. It says iterate with a human. That's from the agent perspective, I guess. The agent and the human iterate together on some kind of plan or specification. And then after that, the agent can maybe run largely unsupervised because it's been given a kind of like a good spec for the work it should do. But some people also like to run things more in hand-holding mode, where they check its work along the way. And so as you start to use these tools, you will develop a kind of sense of when it's best to use one mode versus the other. But what's crucial here is this is very different from the kind of like old school over-the-wall type NLP or ML that maybe a lot of us are used to, where someone goes off, they run some results, and you go and you get back a spreadsheet and you check all of those results. It's a really different skill to learn how to think about some of these. So some examples of some tasks here. These might be ontology-oriented tasks, including complex tasks like thinking about how to refactor the whole branch of an ontology, come up with a plan for a migration of existing annotations for that. Maybe moving to the top right, reviewing all of the annotations made by a particular annotation pipeline, looking at all the papers supporting those annotations and making recommendations. Moving to the lower left, maybe it's something like researching the mechanistic basis of a disease, surveying hundreds of papers in that domain, and then building some kind of like model of that disease that explains each of the individual phenotypes. And then on the bottom right, maybe a kind of more pathway curation-oriented task here. So it might be review the existing curation of an existing signaling pathway that was maybe made a few years ago, check it against our existing latest curation guidelines, suggest modifications for this, survey the literature to fill any existing gaps. And this is not hypothetical. We've got kind of like some tools already that are making inroads in these kinds of tasks. We're going to hear a lot about the ontology-oriented tasks from Aleix later on. And I put some links so I'll share these slides later, and you can kind of follow along and kind of like see some of these. But basically, again, just to emphasize again that, agents are great, but they really need skilled drivers. And I like to think of this not as a human in the loop, but as a human out the loop kind of pattern. So you can make use of agents to do these complex tasks end to end. And examples of these include the agents we've got integrated into an increasing number of ontology trackers now. But a much better pattern is to actually work with the agent and to essentially collaborate with the agent, treat it as a co-curator. And I think of this as kind of supervising from outside the loop. And think of this like managing and onboarding a new team member. If you've got a new team member, maybe you want to be in the loop at the beginning where you kind of like observe them and, learn what some of the things that they maybe need more training on, but increasingly you kind of like start to give them more autonomy, and you essentially step out the loop and you maybe check in on them from time to time and so on. And I think it helps to think about agents in the same way. So I'm going to give you some tips, not necessarily kind of like tips that you can make use like starting tomorrow in your creation work. I'm not going to give you a prompting guide or a kind of single workflow here. I'm really going to try and give you some of the tools and framework for starting to learn how to really use this technology more effectively, and ways to kind of like think and prepare about what is coming ahead. So when I speak to curators about this, the number one thing I hear is that they feel they don't have time to learn some of these practical AI skills. And, they will say things like, look, I've just got this giant stack of papers and I'm maybe graded on how many papers I curate every month or something like that. I just can't take time away from this task. But really, you have to kind of like figure a way to kind of like carve out this time. I'd say at least an hour a day, and definitely speak to your PI or supervisor about carving out this time. And I tend to find that supervisors and PIs actually agree. There's just some communication problem. It's not being communicated that people should be setting aside this time for learning. Once you have that time carved out, really take the time, dedicate it to both kind of like structured learning, but also just exploration and integrating this into your kind of like day-to-day work. And this is definitely worth the investment many times over. It may be frustrating at first. Things may go slower at first, but please just persevere and keep trying. And just if you are a kind of like a PI or supervisor, there are countless studies that show that giving people more time to learn new skills on the job will pay off both for the individual and for the organization. You also have to really make sure that you have access to the tools that are appropriate for your needs. Your time is too precious to be using a lot of the kind of like the hamstrung free AI models that you get out there. You really need something at the level of a pro. Maybe later on open models will be good enough, and you won't need to kind of like pay money for for a company to do this. But of course, you should not be paying this out of pocket, and you should not be having to navigate a lot of the frankly kind of like very baroque and complex kind of pricing plans that you see for some of these models. So really, essentially, you should be speaking to your supervisor PI, figure out maybe there's institutional access that you have to a lot of these models, but check, because a lot of these institutional access might not give you the full features that you get otherwise. Really, it should be pretty straightforward to cover subscriptions for these services from existing project funds. And there's other routes too. You may find that some of these providers are actually very happy to provide access for interesting academic projects. And really, if you are a supervisor or PI, figuring this out for your staff is your number one priority. All right, maybe in the interest of time, I'll go a bit faster. So one thing that you actually can start putting into practice today is something called deep research. And deep research is formally agentic iterative search over the web, which includes over databases, PubMed, and so on. You can think of this like having an army of research assistants. You can give any kind of like research task to it, and it will produce a report to your specification. It can give you a kind of like a detailed kind of like review paper type report, or it can give you a kind of like a high level kind of like a brief or summary. And you can use this to research diseases or maybe even a particular mechanism in a disease. There's a large number of different options here. Definitely try exploring these. Again, referring to the previous slide, figure out if there's a way you can kind of like access some of these yourself. This is some results of just a Perplexity query that I did. This is probably over a year ago now, just about a particular mechanism of how genes might interact in a given biological process. All right, so maybe this is of all the slides, maybe this is one that people might kind of like push back most on. But I really think it is worth all of you trying to learn how to use some of these local agentic tools, including coding tools like Claude Code. And the reason for this is that most of these web-based AI interfaces are really inherently constrained, as they lack access to a lot of the tools that you need for your day-to-day work. And so there's this kind of like new kind of like class of tools, and they're often called like agentic coding tools, but they're really not just for software. Just hands up if you saw did anyone see the Super Bowl yesterday? I didn't see any hands, but yes, great halftime show. But yeah, but there was also, in amongst all the slew of kind of like AI adverts, you're starting to see a number of kind of like adverts for just kind of like general agentic kind of like office style tools. And maybe some of these will take off, but I tend to find that Claude Code, even though it may seem more intimidating at first, it is like by far the best tool for doing a lot of very powerful agentic operations and doing things locally. And there's a screenshot here of just me asking it to do something like go through all the PDFs in one of my folders, read the papers, and just make a kind of like a table of data for that. And it will do much better at this kind of task than using kind of like tools on the web. So it's, you might have to get outside your comfort zone here, but there's a lot of resources to help you here. There's Chris Tabone's tutorial, and you have a lot of colleagues in your institutions who can help you with this. Yeah. Also, have a kind of like a think about your role in your organization. AI, there's no question about this. I think AI is definitely changing how we work. It doesn't necessarily mean what people think it might mean at first, that our work is going to be kind of like phased out. We saw this initially in radiology, where AI performed stunningly well on interpretation of images, but yet 10 years later, the demand for radiologists is higher than ever. Similarly, in software engineering, starting really quite recently, in the last few months, there's been a massive sea change in software engineering, and programmers are not programmers anymore. Increasingly, fewer and fewer programmers write actual programs. But nevertheless, we still need all of these software engineers because we need people to engineer complex systems. And the way a lot of software engineers are thinking about this is they're really kind of like thinking of themselves as managers of agents. So I encourage you, to start thinking about how you might kind of like, level up on some of your roles, kind of start transitioning to do higher level tasks. I mean, more of a kind of like, a management of agent type role. All right, so that was my condensed thoughts on this. So thank you very much to all of my colleagues who have listened to me kind of like rant about this over the last year or so, and kind of like maybe tame down some of my kind of like thoughts on this. But really just to kind of like emphasize that there is increasingly a larger amount of excellent training material out there. I've put some links here. Some of these links will continue to be updated. And I'm sorry, I jumped past one slide. This is a really important one. So please also think about forming a community of practice. We obviously have this in this biocuration community here, but maybe also think about just kind of like in your own Slack workspaces for your own work, forming kind of like channels and get together and share experiences with people at the same level of you and try and kind of like support one another. I encourage everyone who's not here on the Obo Slack already to join the Obo Slack. There's a number of, it's an open Slack. There's a number of kind of like channels for discussing things like kind of like AI and curation with like-minded people. So with that, here's some links. I'll share the slides later, and happy to take any questions, or we can save some of these until after some of the excellent talks that we have coming up now.
So we have like a couple of minutes left if we do want to do a few questions in addition to what's in the chat, or we can just move on. Maybe, Chris, if there's some questions in the chat, if you want to sort of respond directly, and then we can have some more discussion later on. Is that okay?
Yes.
All right.
Do you want? Mm-hmm. Shall I just kind of work through them here, or? Let's see.
Well, I think maybe we could just do that sort of like online.
Oh, yes. Okay. Yeah.
Yeah. Sorry. Mm-hmm. Okay. Or if that's okay. And maybe just kind of go ahead. So Pengyuan, is it okay? I'm going to introduce you next. So we have our next speaker, Pengyuan Li from MIT, IBM Watson AI Lab, and he's also team member at the University of Delaware's data science production, since we have a moment. His research focuses on large-scale multimodal and foundation models spanning data acquisition, model training, and deployment for real-world scientific and enterprise applications. He has a strong background in biomedical document and and image analysis, and more recently has been working closely with the Biocuration community on understanding how large language models can responsibly support evidence-based ontology-aligned curation workflows. All right.
Yeah, thank you, Leonard, for the nice introduction. Yeah, can you all hear me well? Do you want to double check?
Good.
Good, perfect. Yeah. Good morning, everyone. Yeah. Thank you for the opportunity to speak today. I'm Pengyuan Li. Actually, I train a large language model or large vision language model at IBM. I'm also super excited about using AI technology for the biomedical applications. Today, I'm going to introduce an ongoing effort called CurateBench, a benchmark designed to evaluate large language models on structured, evidence-grounded, ontology-aligned biocuration tasks. This is still work in progress. We have started with a licensed number of resources, and we are actively seeking feedback from the community to make sure this benchmark reflects the real curator workflow. Yeah, today, as Chris mentioned in the last talk, right, there many groups are trying to use LLMs for biocuration, but there are so many models, GPT, Gemini, Llama, Q1, and many others. And they have new versions almost every few months. It's very hard to know which one is truly reliable for real curation work. Our goal here is to build a shared evaluation framework for LLM-assisted biocuration. We aim to align evaluation with real curator workflows where outputs are structured and ontology-based. We also emphasize evidence-aware modeling extracted facts must be supported by experimental evidence and proper provenance. Ultimately, we want to support responsible and transparent adoption of LLMs in biocuration. So this is a slide that shows how we translate real curator workflows into biocuration into benchmark tasks. Curators first read the full paper and identify gene fact relations. This corresponds to task 1, ontology-aligned fact extraction. And then next, curators search for supporting experimental evidence. And then this becomes to task 2, evidence retrieval. They then assign structured ontology terms and evidence codes. This motivates task 3, evidence-supported structured generation. And finally, curators record provenance and ensure correctness in the database. Therefore, we evaluate models using evidence baselessness and hallucination metrics. In summary, each CurateBench task directly maps to a concrete step in the Biocuration workflow, and that's our goal. Now let's look at the task 1, focus on ontology-aligned gene fact extraction. Given a full text paper, the model is asked to extract the structured gene ontology annotations that align with curated output from Alliance data. The input is a full article, for example, in PDF or BioC format. We prompt the model to extract the gene fact. The output is a structured list of gene fact statements. We then evaluate the extraction against the curated ground truth. For evaluation, we use precision and recall. I will briefly show you the steps in detail. For the task 1, we use the curated ground truth data from the lines of genome resources. The example shown here illustrate a structured disease annotation record. Each entry contains a standardized ontology identifier, such as a DOID term, the associated gene identifier, the registration type, and the linked publications. This allows us to transform the structured JSON annotation into a clear gene disease statement, along with the supporting publications. The important point is that this data is already curated, ontology-aligned, and evidence-qualified. Therefore, it provides a reliable gold standard for evaluating structured fact extraction. This slide shows a concrete example using one paper on the left, and on the right, you can see the curated annotations from lines organized into different data categories. Each of these statements represents a structured gene ontology association that has been manually curated. This serves as a ground truth for the task 1 evaluation. Next, let's look at how to use current model to do the fact extraction. To perform the fact extraction, we use a structured prompting framework. In this prompt, we define the task definition and give a detailed instructions for each data type. And we also ask the model for each extracted item must include a structured statement following the statement we provided and the corresponding evidence sentences from the paper. This structured prompting approach is consistent with the work we previously presented at the Biocuration Conference 2025 in the context of the gene summary generation work with Regina and Valerio. And this table shows the number of gene facts extracted using the structured prompt that I have shown. We can see clear difference in behavior across models. For example, GPT-5 extracts more biological process and expression annotations compared to GPT-01 and the 4.0 model. Well, the GPT-4.0 produce fewer total facts. At this stage, these numbers reference only the raw extraction counts rather than precision and recall. The key point here is not that one model is universally better, but that different models behave differently in the extraction tasks. And in these slides, we compare model outputs against the curated ground truth and classify predictions as true positive or false positive. we use GPT as a judge to help assess matching between predicted facts and curated ground truth annotations. And I have to admit, actually, GPT model knows much more than I do and give very strong and good judgment here. We then, based on this, compute the precision and recall for each model. What we observe is that higher extraction counts do not necessarily translate into higher precision or recall. For example, GPT-5 extracts more total facts, but also produce a larger number of false positives. In contrast, O1 model produces fewer total outputs, but achieves a relatively higher precision. This highlights an important point. Models differ not only in coverage, but in how aggressively they generalize. We must evaluate both precision and recall to properly assess model quality. And this is just a showcase of how we do the task 1 evaluation. And then now let's move on to the task 2. Task 2 focuses on the evidence retrieval and grounding. Instead of asking the model to extract facts, we provide a curated gene fact and ask the model to retrieve the supporting experimental evidence from the paper. This mirrors an important step in Curator workflow, locating the specific experimental evidence within the paper. The evaluation pipeline is straightforward. We provide the full document and the gene fact statement as input. And then we ask the model to extract the supporting evidence sentences from the paper, and then evaluate the fact evidence pairs using either manual review or LLM as judge. And the evaluation goes beyond a simple sentence matching. We measure evidence in multiple dimensions like faithfulness, hallucination rate, and where the evidence sentence comes from. And for the task 2, the data setup is very similar to task 1. We use curated gene ontology annotations from the lines as ground truth. The difference here is we use the curated statement as input and ask the model to retrieve the supporting experimental evidence from the paper. So the data source is identical, but the objective shift from fact extraction to evidence retrieval and grounding. Here we show an example of task 2, evidence retrieval on the same paper. On the left side is evidence extraction using GPT-5 model, and on the right is the output from the GPT-4o model. At the first glance, both models retrieve biologically relevant sentences. However, does these sentences truly justify the curated annotations? That's a question we want to answer. And on these slides, I show how we evaluate extracted evidence sentences. We use GPT as a judge to assess each sentence. We check whether the sentence truly appears in the paper, whether it comes from background or experimental sessions, whether it directly supports the curated fact, and whether it contains hallucinated content. So this part is a sentence level evaluation. And you do see there is some evidence actually extracted from the background. And then next, we aggregate all the judgment at the paper level. You can see, although given the same number of the gene fact to GPT-5 and GPT-4o, the quality of the evidence extracted differs. From the final results, GPT-5 appears more grounded overall. It achieves like 100% coverage of experimental evidence, basically saying for each of the evidence extracted for the evidence extracted for each gene fact, it will include some evidence from the experimental section. And also GPT-5 provides a lower hallucination rate compared to GPT-4o. I think this is also consistent with when GPT-5 first come out with their branding, saying GPT-5 is more grounded with fact for document analysis. Now, let me briefly summarize how we evaluate models across these tasks. We evaluate models along 3 dimensions. First, ontology alignment. As annotations are structurally correct. Second, evidence grounding, to answer other claims supported by real experimental evidence, not just background attacks. And the third, the faithfulness and the reliability. Does the output avoid hallucination? A model is curator-ready only when it is both structurally corrected and evidence-grounded. Given the short time today, I will move on to the key observations and final conclusions. So what do we observe so far? First, similar fact extraction F1 doesn't mean similar curation quality. Second, many supporting sentences are extracted from the background, not experiments. And third, the evidence-aware evaluation separates models more clearly. So evaluation design directly affects deployment decisions. And to conclude, CurateBench aligns LLM evaluation with the real curator workflow. Instead of generic QA style metrics, we focus on structured ontology-aligned and evidence-grounded annotations. Our results show clearly that evidence grounding is essential for trustless structured output. Extraction alone is not enough. And currently, our evaluation focuses on aligns worm-based data, but this is ongoing work. Next, we plan to expand to additional species and annotation tabs. We also aim to build a public benchmark and a leaderboard so that biocurators can transparently compare models and understand which systems are suitable for practical usage. Finally, we are actively seeking community feedback, especially on task design and evaluation criteria, to ensure this benchmark reflects real-world curation needs. And thank you. I welcome questions, feedback, and suggestions maybe at the end.
Thank you. That was really fantastic. I just have to say there's like 85 people on this call, so I think this is all really important and really very, very timely. So I'm just going to move on ahead and introduce our next speaker. Keep the questions in the chat coming. And Aleix Puig-Barbe, sorry if I'm mangling your name, I should not have done that. Barbe from the European Bioinformatics Institute. He's an ontology editor there. He began his scientific career in the laboratory conducting research on fruit flies during his PhD and postdoctoral work combining experimental and bioinformatics approaches. He later transitioned to biocuration and ontology development, working to organize and integrate biological data into structured knowledge frameworks. His work focuses on developing and maintaining ontologies, more recently exploring how AI-driven approaches can support and enhance ontology editing and curation workflows. Okay, take it away.
Thank you, Lena. My name is Aleix Puig. Can you see the presentation okay in slideshow?
Yes, you're good.
We can.
Perfect, thank you. So my name is Aleix Puig, and I will talk about how we have implemented an agentic workflow for ontology development in EFO. And to give some perspective, before 2023, we had to do manual curation mainly. But only the last 3 years, this has escalated so much that first we had the first LLMs that they hallucinated a lot with GPT. And then with Perplexity first, it was a bit improved, but then RAG really made a change. And now in 2025, we had the Agentic AI and MCP that allows us to do so much more for curation and tools like, for example, that we use all roads to literature. MCP allows us to allow the agent to access to literature. And the last few months, we even have the skills that then they can be integrated with agents as well, and for repetitive tasks, even improving their performance. So we have adopted GitHub Copilot agent. There was a bit of discussion in the chat I saw. Unfortunately, our organization policies doesn't allow us, or we cannot use Claude or another AI at the moment, so we use GitHub Copilot. Also, I say that it's $10 per month. I know that some of you can have it for free with your EDU emails. We can't at the moment. We still have to pay, but well, it's cheap compared with other AI. So it has also a native ID and GitHub integration. It has access to multiple LLMs, and it has been optimized for GitHub ecosystem, but also it has its con because everything arrives a bit later. So subagents arrived in October 2025. Skills only arrived 1.5 months ago. Also, they have limited premium requests that are called every time that you use the agents, if you use one of these, or 3 if you use a more advanced LLM. It has limited autonomous task performance and is not the strongest agentic reasoning engine alone. However, it worked quite well. In our experience, we know that Claude would work better, but it's what we can have at the moment, and maybe in the future we can migrate to Claude. So one of the advantages to use as well is that it uses the same file structure than Claude. With agents are markdown files. It has a YAML formatter where you specify the name of the file, but also the description, the model, and also tools where you can enable all the MCPs that you want for dictation. And then you give all the instructions in the file. Something important is that you should have your repositories with the firewall enabled, hopefully. But this makes that you cannot access to other external resources. And you can give this access through this custom allow list. So this is good, for example, for ontologies. If you want to import from external ontologies, you can give access to the URLs for these external ontologies to download the mirrors for the imports. And also you can configure your MCPs in your repositories. So probably some of you, if you have been working with GitHub and you have GitHub Copilot Plus, then you have seen next to the assignee, you have seen this button. So when you press it, you have this menu where you can give further instructions to the agents in this prompt. Also, you can send the task to an agent in a different repository. For us, it's helpful because in EFO, they request many terms that actually need to be added in OVA. So just with this button, I can just send the request to OVA, and the agent in OVA knows how to add these terms. You can select the branch. You can also change which agent to use. And finally, you can also select which model to use. Now, there's also Opus 4.6 that is quite new. And you can see that it uses more of these premium requests. And once you assign the ticket to these agents, then you will see these googly eyes in the ticket. So the way we design this agent workflow in EFO is mainly this coordinating agent is the main agent, the main copilot agent, that it has all the necessary request instructions to read the ticket, and it has handoff protocols to know how to access to the other agents, when to access, which prompt to give, and for a successful handoff. And then, And then the other agents, we have a curator agent that mainly it can verify or find new definitions, synonyms, logical axioms, by accessing the literature through an MCP, the ARTL MCP, called All Rows to Literature. Also, we have an importer agent that it has all the whole workflow to find terms in other ontologies through the OLS MCP and import them. And finally, we have an ontologies agent that is the one that implements all the changes in all the files. So we have everything separated for a better performance. So I will show you a couple of examples or use cases where we have used these agents. For example, in EFO, we have many terms that are responses to an entity, and some of them are response to chemical entities. So we wanted to have relationship from these terms to chemical entity, chemical ontology, such as KEVI, by adding logical axiom has primary input, some, and this KEVI ID. So we asked the agents to do that, and that would take a long time to a curator to do that, because you have to find all these terms and then find which ones are chemical entities, and then look for them in OLS or in KEVI. But the agent did it very fast. It could identify 116 terms. 32 of them were specific drug terms, and 47 of them were for, drug classes. And when it has categorized them, it called the importer, not to import the terms yet. It was to find which of these terms have, which of these drug classes have terms in KEVI. So once it has found all these terms, it can start first look which one has been imported already, and then access through the OLS to import the terms to EFO. Unfortunately, at the time, it found network limitations because OLS server was down. So it just added the axioms to the terms that were already imported. But I asked again once the server was reestablished, and then it imported the rest of the files, and it could completely complete the task. So at the end, it's good as well because it gives a report. You can find all the EFO terms and the KEVI terms that are related now. But we also wanted the agents to create new terms. And for example, one task that it was quite good at, it's to find new terms in the EBA knowledge graph. So in the EBA knowledge graph, we have multiple databases, such as the GWAS catalog, that have their traits already mapped to EFO terms. However, sometimes they're mapped to very general terms, and we have queries that look if it matched these traits, GWAS traits, with the EFO terms. And if they're not, we can look into adding these terms through an MCP to these queries. So we did that, and it identified through the MCP. You can see that it could access. It found 93 GWAS terms that they don't match with the EFO IDs, EFO terms, sorry, the labels. So it looked into them, and then the curator started looking into the bibliography for each term. And you can see that it provides different papers that support the definition. It also suggests parent terms. It also have the logical definition that we ask for the pattern, and also it provides synonyms that it can categorize between exact, related, or broad or narrow, depending on some instructions that we have given. So it successfully could import all these terms. And one question that we have now, and that I want to ask you, is how should we record all this provenance, how we should record the provenance with the AI agents? Because at the moment, for new terms, we add this annotation property term editor with AI agent, but sometimes we only want to edit a definition or a synonym, to import synonyms. So maybe it's too much to import to add this information, but probably we should do it. And how it's something we have to talk about. Something for the future is now we have these agents, but we don't use skills yet. So probably we can improve and their usability of all these workflows with skills instead of having the agent figuring again and again how to do these tasks. So this is something we want to implement now. And finally, just a summary that AI now currently is helping a lot with both with data curation, ontology development, and in summary, it saves ontology editors a lot of time. So I want to thank everybody in our group and people who has been helping in the last few months and years. If you have any question, I will be happy to answer.
Thank you. That was fantastic. Yeah, we'll definitely get to a lot of the questions are happening and being responded to in the chat. So we'll just move on to our last speaker before we open things up more broadly for discussion. So Chris Tabone is a senior programmer analyst at the Jackson Lab in the lab of Carol Bolt. His work centers on database architecture, systems management, and the development of biocuration software for Flybase and the Alliance of Genome Resources. He previously held postdoctoral fellowships at Trinity College Dublin, where he studied fruit fly behavior, and Harvard University, where he focused on neuronal modeling. Prior to his current position, he served as Biocurator of Flybase. His expertise lies in the software integration and infrastructure of model organism databases, with a recent focus on the application of large language models to enhance biocuration workflows and tool development. So Chris T, take it away.
Okay, so thank you very much for the opportunity to speak today. I just put a link to my slides in the chat if anyone wants to follow along or save it for later to look at stuff. So I'm going to I'm going to show a couple slides here with some background for this program that we've been working on at the Alliance of Genome Resources, and then I'll jump over for the Ever Dangerous live demo and kind of click around the program and show everybody what it looks like. So let me just share my screen here. Okay, so does everyone see my screen there? Does that look okay? All right, so let's get started then. So AI for curation, we've heard a lot of really great things today about AI for curation. And I think the question that we ask here is asked by many people in many groups all the time, ever since LLMs came on the scene. How can we best utilize these LLMs for curation? And we want to know at the Alliance of Genome Resources. So we have a large number of curators there from a number of different model organism databases. There's a ton of expertise. Curation we believe can be sped up by LLMs, but we want to do it in a way that's safe and reproducible and has proper guidelines and avoids hallucinations and things of that nature. So when all the LLMs were making the news and they first came out, we started with an early version. We called it the Biocurator Assistant version 1 in 2023. It was very basic, and I think a lot of people have taken the same approach we did with these models, which is basically you give it a PDF and you ask it some questions and you see what comes back. So back, 2 years ago, which I guess seems like an eternity in the way that these LLMs are progressing, they were okay. They weren't the best at retrieving things. Hallucinations were definitely an issue, and it just wasn't very thorough. So we did some experimentation a couple of years ago, but then we started revisiting it more seriously with the creation of newer, more modern models at the end of last year, and we wanted to know what else can we really do to push these things and to expedite curation in an accurate way for everyone that works on the project. So version 2 of this, it's still driven by the same goal, which is to extract meaningful information from publications for curation. Now we have a couple more guiding principles, I guess you can call them this time around. The development is very, very heavily focused on curator input. The use of LLMs it's a weird intersection because they're not deterministic, they're not programmatically constrained in a way that traditional software writing is. So things like prompts, for example, that can take a lot of input from curators can drastically alter the outcomes of these LLMs when they're used for this purpose. So that being said, the curators are the ones who probably know the prompts best for when we're asking the questions to the LLMs to get the information that we want out of papers. So it's kind of essential to have curator-driven development in this sense if you're going to get the best response from these things. We've shifted to a more of an agentic approach. We heard a lot about agents today. There's many reasons for that. I'll go over a little bit more later. We have a new user face for this. And like I mentioned, is that another bullet point that curator feedback is critical. The other thing we wanted to look at when building these programs is auditing. So the LLMs and a lot of times can be a giant black box, and we don't know what they're doing. We don't know what's going on. Sometimes when they reason, we can find out what they're doing, what they're quote unquote thinking. When they make tool calls, we can see what those tool calls are. We can look at what gets requested and what comes back. As a part of this development for this new version of the program, we wanted to create an audit system. So a curator or a developer could look at every single step of this program and see what's happening and kind of make that black box as visible as possible and leave a paper trail that can be verified later to make sure that it's not doing things are going off the rail. And then also hallucinations are still an issue. We have several guardrails in place in our new approach here. Programmatic confirmation, where if the LLM says it got something from a paper, we can then do just simple string matching back to the paper to make sure the data actually came from the paper that the LLM claims that it did. So the version 2 of this is built really thoughtfully with a lot of what we've learned over the past years from just experimenting with these models. And also, let me show a basic flow of how this works. It's very straightforward, the overall flow of the program. This is a simplified view. This is your really high-level view of it. We take PDFs and we ingest them into a vector database through some embedding. That is then fed into this program, the Biocurator Assistant, which is an agentic program. I'll show one more slide of that in a second. This program is what curators interact with. So they can chat with the AI. They can also create what's called flows for the AI, which again, I'll show in a second. And they direct the initial agentic supervisor, and the supervisor is then in charge of sending off other agents to do the tasks. And the supervisor decides what's important according to what the curator asks, and then it dispatches these to get the job done. In our flow version of the program, the curator can actually outline the entire flow from start to finish of which agents are used in what order, and give them extra instructions. I'll show that in a second. And then the program outputs CSV, JSON, TSV, or a format for the database. Everything that we do is curator approved. So nothing goes in without final curator approval on this. And so they will stamp off everything, make sure that it looks good. If it's not, they can converse with the program some more. Why did you do this? What happened here? Is there a developer issue that needs to be addressed here? And so this is the basic flow. It should, hopefully, when it's completely in production, we're still in pre-release, empower curators to go faster, be more efficient with their work, but in a way that accuracy is key, reproducibility is key, and avoiding things like hallucinations, again, is very important as well. So the view of what happens in that box in the middle there, like I mentioned, we have a supervisor agent. If you chat with it, you give it the responsibility of reading your chat and choosing which agents to send to the task. These are a couple example agents that we have. If you want more control over the program, we have a system called flows where, again, you can outline the exact flow you want these agents to follow in order to get the task done that you're requesting of it. Because of this kind of breakdown with the supervisor agent dispatching other agents, we have support theoretically, and we'll push this and try it for hundreds of agents to do very specific things, whether they're curation-specific tasks that are specific per mod, or even user-specific defined tasks. If a user has a specific thing that they want, we can create an agent for them, and then that agent can do that specific task, whether it's processing a paper in a specific way for one user, or just doing something they have at hand. And these agents and these prompts and these flows can be shared amongst users of the program. We have a batch mode that supports using these predefined flows I mentioned, which I'll show in a second, to process dozens of papers at a time. And then this entire system works via API. So it can be inserted into some of our existing pipelines where we can have a situation of a whole bolus of papers comes in, curators have flows that they would like to run on those papers, and the curator would then open the program and review the output from all these processing pipelines. Okay, let's hope this works. It should work fine. Let's do a little demo. So I want to show you the actual live program that we have here. Okay. So this is the interface that we have right now for the Alliance of Genome Resources. This is an example where I've already asked a question, so I'm going to go over some things here, and I'll ask an additional question so everyone can see it working. So this is the chat interface of the program. On the left is your PDF that you can load. In the middle is your chat panel where you can interact with the supervisor agent, and on the right is our audit system. So you can see here, I've asked a question here, what genes are the focus of this publication? And when you start with a question like this, it starts this whole process on the right. And you can see the agent gets initialized, it does some queries, it calls a PDF specialist, and you can actually see some of the prompts here that are requested of the PDF specialist. And this prompt here is formed from my question, but the supervisor has instructions to basically translate that into something that would be useful for the other agents to run. And then you can see this PDF extraction agent. You can see which sections it reads, the title, the introduction, different statements. And then it starts looking, and another agent is then called, which is our gene specialist agent. And what this does is it verifies the things that are found from the paper against the Alliance curation database, so that the first part is extraction, the second part is a verification. That goes on. If the verification is not up, so you can see here, the verification comes back, the agent thinks about it for a second, and it dispatches for a few additional things that it would like more information about from the database. So we leave it up to the supervisor to see how much the task is, quote unquote, I guess, done. And it can loop several times until it feels confident that it's not getting any new information, that all the information has been validated to the best of the ability of the other agents and the database that it has at hand, and then it returns that back to the curator in the form of a chat here. So I can extend this. We'll ask one more question here. We'll say like what transgenic plots are used in this application. So we'll ask a question here. It'll fire up the system here on the right. It is slow right now. We're prioritizing accuracy over speed. I mean, really, that's always going to be the case. This is using GPT 5.2 models in the background. The reasoning is turned on, so they spend a little bit of time thinking here. It seems to be worth it. We're still working on benchmarks. You know, can we turn off reasoning for certain tasks? Can we make the model slightly faster? But again, you know, accuracy is the most important. And so if it is a little slow, these are things that could be run in the background while curators do other things. But I am confident, you know, this is early days. We're still in very early pre-release. It's only been a few months that we can speed this up even faster to hopefully get accurate results. So you can see here it's spinning up the supervisor. It's then calling this PDF agent here, and it's going to say to extract all these things from the document. Gal4 looking at UAS, searching for all these things. It's done searching the document. And the nice thing here is I said which transgenic flies are used, and it took upon itself to actually mention, I can't scroll up while it's working, but oh, you can also see the paper, it highlights as it goes. So you can actually look at the sections that it's reading in real time to monitor it. And then when it's done, it can highlight those sections for you at the end to say, you know, this is where I extract this information from, and so on and so forth. So it's scanning through the paper right now to look for all these different things. It's reading the methods. It's looking for specific strains here. It should be just about finished here in a second. Time is still good. Okay, cool. Looking at the supporting information. It likes to be thorough. And all these things can be adjusted by the prompts that we use in this program. It's interesting finding a balance of being thorough and taking too long, and how do you shape a prompt for a supervisor that, you know, it doesn't know how much information is in the paper total. So you have to find a nice balance between you're not getting new information back. It's a good time to exit the loop and provide what you found to the curators, synthesize what you have to the curators. So while this is still going, I'm going to show another aspect of the program, and oh, might be finished actually. Hang on. Maybe it heard me saying that. Give it 1 second to synthesize its data here. It might do some validation for genes or alleles for this. It also might just going to synthesize what it found. Great. So you can see here now, this is the supervisor coming back and giving this response to us. And this is correct. It talks about the mosaic stocks in the paper. It highlights some of the strains that are used. Not found in the PDF. It says stuff that it couldn't find. So we don't have validation for transgenic stocks yet, and it actually comes back and says that, which is really nice. We will have that at the Alliance at some point, but that data is not available now in our database. And it tells you where it got it from. And there is some highlighting, but it clears right now. It's still staying. So you can go back to look and see these are the parts of the paper that it felt were the most important for what it returned. So that's the chat interface that we have for this program so far. If I'm going to show the Agent Studio, which has some more things. So as I mentioned earlier, one of the things we're really trying to emphasize here is curator-driven development. So if you get a response like this in the chat, there's actually some buttons here. You can provide feedback right to the developers here. So if you were to type a message and click send, this will actually summarize the conversation. It'll send the developers the trace. That the trace is kind of all this logic on the right, what the LLM did. And that all gets sent to us. So things that don't work or things that are missing, when they provide feedback, they can say, listen, it missed these transgenic lines. This information is hallucinated or not accurate, so on and so forth. They can provide that feedback to us, and then we can act on that as developers. And when we get feedback from the curators, there's a support program written for this that we call Trace Review. And Trace Review lets all the developers dig really, really into the details of what exactly happened, down to the cost of the calls that were made, the number of tokens or observations that were used. With this Trace Review program, we get this trace from the curators or from the database when things run, and we can really break apart the conversation to show like what tools were called, which prompts were sent. So if I click on tool calls here, we can see exactly what it's calling to the database. We can see exactly the document searches that it did, what it actually looked for. You can look at the raw input JSON and things like that. We can see which agents fired. Again, like I mentioned earlier, token costs for this entire thing. You can look at the document that it searched for and all the parts of the document that it looked through. So literally every single piece of information that we can pull out of this pipeline is available to developers to further troubleshoot the platform to improve it for curators. And then curators can also take this output here, and they can do something where they can click this and says open in Agent Studio. That's this link up here. So if you open something in Agent Studio, you can then talk with this panel on the left, which is a Claude. So I can say, discuss this trace. Can you help me understand what happened? So let's say the response you got was not very good. Well, you can fire up Claude here. Of course, it's not working. Okay, so that's the risk of a live demo. But Claude can actually analyze this trace and then respond to the curators with the same knowledge that most of the developers have to say, okay, this is what happened with your thing. This is why you're getting a bad response from this. And then also in the Agent Studio here, I have another minute or two to show. We allow curators to look at what we call the agent browser and with flows. So the agent browser, you can see everything that works, that runs all the agents for the website. So for example, our generic PDF extraction agent here, if I click on it, you can see some guidance on how to use it. You can look at the base prompt for the agent, for the PDF extraction agent. So these are the actual instructions that are sent to the LLM. So curators have full access to this, and they can see what's going on. What is the prompt that's driving the behavior right now of this LLM? And you can also, this one should work. You can also discuss this with Claude, and Claude will help you understand exactly what's going on. So it's going to do here, PDF extraction agent, what it does and when it's used. And so this panel on the left, again, this agent in the program will help you talk and understand with the prompts that are going on the right. And then the last thing I want to demo real quick is the flows. And this is a kind of a reproducible way to get results from this program outside of just chatting. This is a system where you give initial instructions. You can then pull out, for example, a PDF extraction agent, and you can hook that up to your initial instructions and then do gene validations apart from that, like here, hook this one up here, and then do CSV output like this. And these flows can be adjusted and saved by curators and then reproducibly used for certain PDFs. And this can be done programmatically or in the chat interface with well. And you can also verify these flows with Claude. And I don't have any initial instructions, so it will come up and probably say it's going to fail because you're missing instructions in this flow. So this is the early day version of this program. We're in version 1.12. I think I showed 1.11 for the demo. It's open source, so it's work in progress, though. Feel free to look at the repo if you'd like. It's built in an organizational agnostic design. There's nothing in here that is Alliance specific. So the goal here when we publish it in a couple months, hopefully, is that any organization could take this, drop in your own agents, drop in your own tools or database connections, and adapt this for their organization if they'd like to. So we're building this for the Alliance, but it's also built in a way that it's flexible in its design. And I see I'm kind of running out of time here, so just want to thank some people. We have an AI working group at the Alliance. They're fantastic. I've gotten a lot of feedback here from this group to improve the program, lots of input. So thank you to everyone on this list. And yeah, I think that's about the end of it.
Fantastic. Thank you so much. So there's a lot of people on this call. So I think the way for us to go ahead and do the chat is some of the answers have been posted in the chat. You are welcome to save the chat for yourself, but it will be kept along with the recordings and the discussion. So my suggestion is that as you have questions, If there are questions that haven't already been answered, go ahead and re-ask those questions, making sure to tag the speaker whom the question is directed towards. So sort of with that kind of understanding, I'm going to go ahead and start maybe going through some of the questions. So there's a question for Chris. Or they're adding other kinds of questions.
We have multiple Chris's
today.
Oh
yeah, yeah. Sorry, Chris. So Chris Tabone. So can your tool handle more than one PDF at a time?
Yes, I didn't have a chance to show that demo, but in the batch mode, you can load up. I don't have a limit on it right now, and I think I've tested up to 20. So what you can do is you can make one of those flows I showed very briefly, and then in batch mode load up 20 PDFs and have it go through, and it'll provide you with a zip file at the end in your output format, like so CSV, TSV. And in the future, the next big part of this program that's coming out is going to be the annotation interface. And that will be an interface where the curators can actually sign off on the annotations or on the information that's extracted from the paper. So it'll be a pre-populated field with evidence from the paper, and you can say, this looks good, this does not look good. You can even interact with the models further to be like, why did you do this? Or can you run this again because this doesn't make sense? So that eventually we'll be able to do PDFs in batch and then take all of those to the annotation screen, and you should be able to click through and approve or reject annotations in a bulk method. So we really want to make this fast. If it's not fast, it's probably not worth it.
And then, there was a question from Martin Urban for Chris Tabone. What happens to the PDFs when PDFs are transformed into the vector database? Is there some kind of RAG disassembly?
Yeah, that's exactly what it is. So we're using Dockling right now. Thank you to Pengyuan for pointing that out, actually. He was also on the call today. So it's a phenomenal PDF extraction software called Dockling. We use Grobit a little bit and Marker as well. And so we have this pipeline where we extract the data from the PDF, we put it into the vector database, which is Weave8. So that's a RAG, like you mentioned in your question, which is great. We do a bit of a trick on it, which I found works really well. Some of these PDF extractions suffer from, this is a header to a section, so results in discussion or materials and methods, it has trouble with that. So when we do the PDF extraction in the RAG pipeline, we actually send it to an LLM to say, please find me what are the headers in this document? And the LLMs help us, after the PDF is actually extracted, to parse the structure and to create a coherent structure in the database, which is then very, very useful, because when I ask the LLM, find me transgenic flies, it can look at all the headers and say, oh, there's the materials and methods section. I'll check there first. So that's the kind of RAG pipeline we have set up. And that's all open source too. There's some more documentation I need to add to the repo, but anyone's happy to take a look at that.
Yeah, just to chime in, I'm not a salespeople, but actually I'm part of the Dockling team. Yeah, Dockling is also part of the IBM research product. Just to add on, I think Dockling is not only the PDF parsing tool. Actually, from the Dockling platform, you can also call other language models to do other annotations. I think that is an add-on, actually. Yeah.
Fabulous. Another question for Chris Tabone from Alan Barron. Does asking multiple subsequent distinct questions affect accuracy?
Yeah, that's a really good question. So I built this and I was trying to be really aware of the context window. The questions in the chat fall off from the supervisor, I think after 10 questions on purpose, so that the context window doesn't get too polluted. So there's a warning when that starts to happen. I haven't found any drops in accuracy, I'd say, within the 10 question limit. I could probably push it further. One of the advantages of using these multiple agentic systems is that the context is unique for all the different agents. So you don't risk kind of overrunning your context window, because the new agent that gets sent out is starting with a fresh context window. So you kind of get that's a big advantage to this approach. But yeah, for now, no accuracy drops, and I warn curators that the conversations more than 10 questions are gonna, the old questions will drop off, and then they can keep going with the new questions.
So continuing down sort of from the top, from Catalin, another question for Chris Tabone. So since you haven't had a chance to like respond in the chat.
No, that's fine.
Can you
Yeah.
give a structured answer? Like, can you provide a table structure and then it fills it up with the answers in the correct columns?
Yeah, so in terms of structured answers so far, we've had success with three types, CSV, TSV, and JSON. And I've had a lot of success with that. So in terms of structured outputs, that's all we do right now. We could do more, or we could write, if you got CSV, it would be straightforward to write a Python program that turned that into something else. So we kind of went with the most popular and powerful structured outputs right now, but the program is flexible. And the way the agents are written, you could write your own agent and it would be an agent and a prompt and some tools to make the output be whatever you want. So there's flexibility. It's in the developer documents there that any output agents could do any number. It's just up to what the LLM can handle.
Okay, and one more for you, Chris Tabone from Nico. Does your curation system currently capture the curated evidence explicitly, or is it assumed that generally the curator validates all the curated information manually?
Yeah, that's a great question. So it's kind of a mix. The program is told, and it seems to do it very well, capture when it's searching through the vector database, capture the actual string that you're using to reference things, and it pulls that out. It's kind of a required component that we have a guardrail on. It's not allowed to come back without evidence. And then for the screen that we're working on now, which is kind of the annotation and extraction approval screen for the curators, that evidence is matched back to the PDF, and the PDF is highlighted. So when you go to approve extracted data or an annotation, you have next to the annotation in the empty screen, you have the evidence that the LLM says, as well as the highlighted section on the PDF. And there's confirmation there that's programmatic, so Python string matching and stuff, to make sure that it's not hallucinating the evidence that it's extracted from the paper.
Thank you so much. So there's a question from Tanya. This is for all of the speakers. So what if you started with one AI solution, say ChatGPT, but now you want to move to another, say Claude? How do you make that transition well without having to start from scratch with all of the history that you've built? So, and that's everybody question.
I mean, I can take a first pass, but I think
Mungall, yeah.
with a lot of these kind of like agentic workflows, the tools that Chris Tabone showed, what Aleix showed with the GitHub Copilot, it's pretty easy to kind of like swap out one model for another. There's advantages to some over another, but those change weekly. But I think what your question alludes to is like when maybe with history, when you use some of the web-based tools, you do build up a kind of history there, and it can be a bit frustrating if you're always going between like I am. 10 different interfaces, and then you wonder, wait, where did I have this chat? And you're trying to find so there's various tools to kind of like export history and so on. But again, this maybe to me comes back to the point of just, the chat interfaces are great, but that is not all that you should be using. And yes, there is a bit of a vendor lock-in where you want to go back to ChatGPT because that's where my 2 years of chat history is at the moment. So.
And
for me,
does
actually,
anybody else?
Sorry. I think for me, actually, these questions are directly saying like we do need more evaluations on all these kind of models because they keep public. As people working in industry, right? Like industry publishing models every few months. That's the trend now. So it's really important to do a good evaluation on all models so that we know which models should go to which tasks or agent, whatever we say. And for me, I feel like just for the personal usage, I feel Claude is doing awesome for code development. If you are trying to do any code relevant or data relevant tasks, I do suggest to go to Claude first. ChatGPT is super good for logics and understanding, I feel. So I typically use ChatGPT to improving my logics and use Claude to implement my ideas. And it's working awesome. Like you can develop a project in a week, actually. Yeah. Thank you.
Aleix, anything to add?
Yes, in my case, well, we have limited access to LLMs, but I found that it's easy to move from one to the other. I also started at the beginning with ChatGPT, and then when I moved to GitHub Copilot, the transition was quite similar. And now all the tools and trying to build them in a way that they can be moved to Claude if it's accessible to us.
Any further statements, Chris, Tabone?
I think everyone else covered it pretty well, actually. Yeah, nothing to add.
Fabulous. All right, so are there other questions that people had that the chat's gotten quite sort of long, so if there's more specific questions that you haven't had a chance to get answered, if you put them in the chat and then tag the speaker, that would be absolutely fantastic.
There was an older question, Lenore, about would it be able to read older PDFs? I think that was for Chris Tabone's tool.
Yes.
Yeah, that's a really good question. So we are hi Rajana, by the way.
Hi, Chris.
So we're benchmarking stuff like that right now. We had an Alliance employee, Pedro, who was with us for a month, and he was writing a whole software suite for PDF extraction benchmarking. So that's a work in progress. I'm sure it's such a tricky problem, especially, you get the ones from like 1970s and you can tell the scanner was broken. It like went up on the side and it's like, how we, everyone has been read those papers. So we'll have to see. We're going to definitely push the limits on this. And we don't really have a solid answer yet, but it's a work in progress.
Thank you. All of those like inaccessible images are really a struggle for getting information out. We still have a bit of time, so are there any other pressing questions? Any thoughts about where do we, collectively go from here? Right? Like I started thinking about how do we collaborate on sort of, benchmarking, right? So these, I'm as a curator very interested in all of these tools to see how they apply to like my organism and my data sets. So is that something that we, collectively can sort of give, to be able to give feedback on that to improve these models? So maybe I'm looking at like, Chris, like, if I were to implement your biocuration assistant, is there sort of a pathway forward for, providing that data back to improve the models?
Yeah, I think that's that's an excellent question. I mean, it's one of the reasons we went open source with it right from the beginning with the MIT licenses. If other people, I'd say it's more mature in a couple months, but people are welcome to follow the repo in the meantime. But any discussions that went back to GitHub on the issues, we would absolutely address and discuss within our group. We have an AI working group at the Alliance, and I'm not sure how open that is. I feel like it should be open and accessible to the wider community. People want to partake in that. That question, I guess, is kind of above my pay grade to the PIs. But I think the Alliance wants to push something like Pengyuan's leaderboard, where that's a curation community-wide discussion on how these models perform. I think that's a really good avenue for reflection on these. But otherwise, yeah, I guess, I don't know, Chris, Mungall, do you have any thoughts on that? Like our group and how to collaborate with these things across the whole organization?
Yeah, I mean, I don't know how I know that we've got this kind of problem of kind of like fragmentation of kind of like Slack workspaces and so on. And
yeah,
there's the ISB one, which is great, but maybe I've not kind of gone back there in a while, but I've not seen so much kind of, I really want to kind of encourage this idea of community as a practice. And I think, ISB could be that, Slack could be a great place to host that. Of course, for anything kind of more ontology centric, we've got the OBO one and everyone is welcome there. I'd be open to opening up the kind of Alliance one as well, but it might be good to have it in a space that is more explicitly kind of like more general than one individual project. So.
There's sorry, Krista, there's a question. What should the predicted workflow look like? I'm not sure who that question is directed towards.
Just anyone can answer.
the projected workflow for biocuration? I'm sorry.
Yes. So, what, like, how should people be able to handle the the automated agents? Would they be able to just feed in a PDF or feed in some sort of literature and get some sort of answers? Just should that be the direct projected workflow going forward?
I mean, I'll maybe start and just kind of say, my hobby horse is like there is no one workflow. We all do such diverse curation. Some of us are maybe kind of like hyper focused on extracting particular kinds of information from a paper. Myself personally, when I work on kind of projects like Go and Monarch, I'm very interested in more synthesis from multiple different kinds of papers. How can we bring this a huge wealth of existing kind of like knowledge from papers, but also kind of computational inference, and use that to build a kind of like a model of a signaling pathway or a mechanistic model of a disease or things like that. So that tends to bias how I think of things. But as I think of it, our workflows are going to become increasingly open-ended, and we're going to be tackling kind of like higher level tasks. We're going to, not just as curators, but as members of knowledge bases and data resources, I think we can start thinking about other kinds of things that were out of scope before, that we can do things that are of more value to our users. And I think we're going to move away from this kind of like narrow kind of like I have this workflow that I run every day type approach to managing agents to do some of the lower level tasks, and us taking on almost more like PI like tasks. So I want you all to kind of put me out of a job, basically. So I want to come back here and you're all doing my job.
Thanks. There's a question from Val. She said, for Chris Tabone, this is a follow-on from my rambling about could the workbench be used to reevaluate and locate text spans to support existing curation to increase confidence in the existing curation gold standard data?
Yeah. So is that trying to support existing curation? Yeah, I mean they could. So using the curator assistant to refine or confirm existing curation. We haven't talked about that. That's an excellent question. That should be totally feasible. We will be interacting with the curation databases to load existing annotations into the software. So yeah, in that sense, I think kind of a confirmation, that's a really good question, actually. I'll take note of that because that's not something we have talked about, and I think that'd be an interesting question to tackle.
Yeah, thanks. That's brilliant, Chris. You've done most of the things we've put in our grants, so hopefully and they're asking us how we're going to do it, so we'll just show them.
Cool, you can use the money for something else.
Yeah.
We haven't got it yet, but yeah.
See my question in the chat.
Yes. I think that we're all converging on things that we're really, interested in. That these are all really cross-cutting ideas. So I want to follow up on Shishma's question in like the remaining 2 minutes about thoughts about how AI agents can be used to mine data that isn't explicitly in publications, such as transcriptomic data. And I guess this is maybe getting towards being able to annotate genes that are unknown function. I got that right. Does anybody have any thoughts about that?
I don't have any I don't see it being not feasible. But I don't have any experience with it personally, but I can't think of any reason it wouldn't work provided the person with sufficient expertise attacks the problem. I mean, there must be groups doing this. I'm not sure if I'm guessing there are groups doing this. Yeah.
Certainly the cell ontology group, this is like a kind of primary focus of what they're doing as well. And I think, again, we're going to see kind of like increasing kind of like abilities to do things that were out of scope before. Like maybe we do want to kind of like bring in some transcriptomic data to help us kind of like just frame some existing knowledge about some gene functions or something like that. Using some of this agentic technology, all it might take is just plugging in a skill for here's how to analyze RNA-seq data. And even if you are not a card-carrying bioinformatician, it's going to be increasingly easy just to have the agent go off and do some kind of like bespoke analysis using the latest tools and kind of like give you back information that can help inform your interpretation of the data and curate appropriately.
Yeah, I mean, we've talked about briefly recreating some of the Web Apollo workflows in something like the Curation Assistant, and all it would take is, like you said, Chris, just taking agents and the appropriate tools and putting it at the data that you need to back up your annotation, and then off it goes, and it's transparent. It returns you what it finds, and then you move forward from there.
So if we've actually at the top of the or the end of our time, and I want to make sure that we have time up. So going to sort of end the questions now. Remind people if they want, you can save the chat, the slides and the recordings. I think will all be available, and it sounds like there's a lot more to come and a lot of potential follow-up. So Marc, do you want to finish up?
Sure do. Yeah, I want to thank everyone, especially all the folks who helped organize and really went out of their way to make sure that speakers were recruited and everybody was sort of on the same page. And then essentially, I don't know which screen I'm sharing. Can you see upcoming events?
Yeah, we got that.
Oh, great. It's just a fantastic opportunity to talk about what opportunities are out there, what tools are there. Funding continues to come up all the time. And the more we work together and the more that we know what each other's doing, I think it's just a great opportunity to keep having workshops and discussion like this. Also, I want to remind you that we have upcoming events, Curation Beyond Biocuration. We have the ISB conference in April, and also there's a virtual aspect to that conference. And we now have Curate This, where you get to see curators in their own environment doing what they do, and another opportunity to sort of take a deeper dive and see how curation works across all of the various resources that our members are currently working in. And I want to thank you again. And that's about the end of our time. Sue, do you want to say something?
Yeah, I was going to just barge in to say that if this group does want to have continuing conversations, so we already have the ISB Slack channel set up for talking about AI and biocuration. But if you guys want to set up a standing time, ISB is more than willing to give you a Zoom channel. We can set it up. If you want to have a standing meeting where you talk about ideas that is, like the Alliance, AI working group, but you want to have a meeting that's independent of a project, ISB could host that for you.
All right. Well, let's keep the conversation going either way and decide how far we jump into the water. So thank you all. We will make all of the resources that we can available, including a recording, slides, and ideally the chat windows as well. So cheers. Thanks so much. Be well. Have a great day.
Thank you.
Thank you.
Bye.